Hello and welcome. Today we shall look at simple machines. Okay, what are simple machines? Simple machines are tools or devices that make our work easier and faster. Okay, we apply simple machines in our daily lives. As you can see, riding a bicycle makes it easier for us to cover a long distance. The bicycle is a compound machine that comprises of 3 different simple machines. Okay, there are 6 classes of simple machine: the lever, the inclined plane, the pulley, the wedge, the screw, and of course the wheel and the axle. You find the simple machines around you every day. A lever is a rigid material with a fulcrum. Okay, the advantage of the lever is determined, or the mechanical advantage is determined by the distance between the fulcrum and the effort. As you can see in this plier here, examples are your opener, your shovel is also a lever. This golf stick is an example of a lever, and the wheelbarrow is also an example of a lever. We classify lever into 3 main classes. The first class lever, in which the fulcrum is at the middle; the second class lever, in which the load is at the middle; and of course the third class lever, which has the effort at the middle. You can see some various examples. An inclined plane, any slopey surface. This skateboard is an example of an inclined plane. Okay, your ramp is an example of an inclined plane. An inclined plane allows you to easily transport or climb up. Even this staircase is an example of an inclined plane. Your pulley allows you to lift things. It consists of a wheel with a groove and a rope around the groove. We either use a pulley to lift things or change the direction of load. Okay, pulley are found every day. This bicycle chain consists of a pulley, and not only that, we also find pulley in crane system, and then we also find them in most cars. Okay, that's for your pulley. Then you have your wedge. Your wedge helps to cut by changing the direction of force. For example, applying the force to this nail, the force will be driven, which pushes this nail inside to some point in which either the force will tear the wood apart or it goes inside. Your scissors is considered a wedge and also a lever. This axe is an example of a wedge. Now your screw. Your screw is an inclined plane with a shaft around. It helps you to drive materials into other materials and also hold things together. This bolt is an example of a screw. Now your wheel and axle simply consists of a wheel connected to an axle. It allows us to carry heavy load from one distance to another. This bicycle has a wheel and axle which carries the human being. This wheelbarrow has a wheel and axle which carries the load. The essence of machine is because of mechanical advantage, which of course is how much an effort is multiplied. We calculate mechanical advantage mathematically as the load divided by the effort. And then we also have velocity ratio, which of course is defined as the ratio of the distance moved by the effort all over the distance moved by the load. Efficiency is how much work a machine can do. Okay, no machine is 100% efficient because some of these energy are used to do work against friction and heat. We calculate efficiency as the output work or work output all over the work input multiplied by 100, because efficiency is a percentage. We know that work done is force times distance. Efficiency is load times distance moved by load all over effort times distance moved by effort. Of course, efficiency cannot be mechanical advantage all over velocity ratio, since velocity ratio is distance moved by effort all over distance moved by load. Let's consider this example calculating efficiency. Determine the efficiency of a heat engine if it gives out 500 joules of heat energy as useful work and its energy supplied to it is 1000 joules. So we apply a formula that says efficiency is output or work output all over work input times 100. Our output work here is 500 joules, our input work here is 1000 joules, and then we'll multiply by 100. That gives us efficiency of 50%. Is it not? Yeah. So this machine, the useful work that can be done is just 50% efficient. You see, the other 15 has been used against friction and heat. That now brings us to the end of this lesson. Thank you for listening. Remember to do your other activities. I'll see you in the next class.